Welcome back to BOS Recreational Gold Mining. Today I've got a little project to do. As you can see, I got a big piece of silver here that we poured from doing basically electrolysis dissolution, basically using salt water and electricity to dissolve the silver off of plating. Got a bunch of it. I can tell you right now, it's not worth your time or trouble to do. So if you think you would like to try that, have at it. Just, I'm not going to do it again after having done it for about 30 or 40 hours. There's absolutely no profit in doing that. The layer of silver on the plating is very small, and a lot of times under that will be copper. If you look at this, you can see that doesn't look like silver. That looks like copper. When it was first poured and buffed up, it looked like silver, but you can see the copper coming right through. Almost silver on this side, but not really. So what I know, this has a lot of copper in it. Probably this is lucky if it's 90% silver. So what I'm going to do is I'm going to remelt this, and then I'm going to pour it into shot so that the smaller shot can have access to a smelting process that has a better chance of taking out the copper. We're going to try and oxidize the copper with sodium nitrate. Then we're going to try and collect the oxidized copper with borax and silica, all in one smelt. But right now we got to make this a lot smaller so there's a lot more contact area when we try to get the copper out of this. So right here is a slightly used crucible. Since we're going to be pouring this into water, I'm not going to add any borax or anything. When pouring into water, sometimes it has a tendency to big lumps will go in all at once, and when that happens, there's going to be a small explosion, steam explosion, which is going to launch melted silver and copper into the air. And yes, your face is usually right on top of it when that happens. So it's a very, very unpleasant surprise when that happens. So I will be wearing glasses, gloves, and I'm going to be pouring it from some height so that my face hopefully will not be right in front of the pour. So here we go. Let's light this firecracker and see what happens. This is a homemade furnace. Uses propane, refractory fiber bricks. Get them online, cut them out. This stuff has no weight, very light. It's almost like space shuttle tiles. This with just a little bit of this will stop a lot of heat. Will keep the heat in. That's what we want. So I got my big match. You don't want to be sticking your hand down in there lighting it. You can throw a match in there, turn on the gas, it'll light. So I'm going to turn on the gas and okay, maybe you can hear me, maybe you can't.
Yes.
Over the noise of the furnace. This furnace is going to take about 5 or 10 minutes to heat up, probably another 10 or 15 to melt the silver that's in it, and then we're going to pour. Okay, in order for the heat to build up, I'm going to cover the top of the furnace and let that thermal heat from the propane reflect back inside on itself, and it'll heat up a lot quicker. As you can see, I've dug out a thermometer here. Way down here on the side, you can see the ceramic holder for the thermometer. Thermometer actually inside, about halfway up, just barely into the combustion chamber. Uses a K-type connection. And we're already up to 800, over 800 degrees. only been 2 minutes.
Centigrade? Centigrade or Fahrenheit?
800 degrees
Centigrade or Fahrenheit?
Fahrenheit. We're going to push the button. I'm sorry, that was 800 centigrade. Now, some of you know that copper melts at a very high temperature, much higher than silver. However, when you combine silver with copper, the melting temperature of both change. The melting temperature of the silver will go up and the melting temperature of the copper will go down. That happens with most alloys when you combine two different metals. Sometimes we do that on purpose, especially in smelting. We add lead when assaying, we add lead to it. The lead lowers the temperature. It also acts as a collector. The lead will collect a lot of metals, and then when you compel the lead that you used in an assay, the lead goes into the compel, leaving behind the precious metals. Okay, the silver pyramid that you saw me put in has just now melted down. It's laying flat in the bottom of the crucible. We're waiting for it to break open. By break open, it means that the top of the melted silver will open up and be shiny and liquid, just like water. And our temperature right now is 1100, right on the nose, Celsius. I don't know if the camera picked it up, but we're just using barbecue bottles for propane. I'll lift one up and show you. We can do this about 15 to 20 times on one barbecue bottle. Depends on how much you're melting each time. Okay, the silver is starting to open up. It's got a little bit of crust on it and it's open around the edges. And our temperature is 1130 Celsius. Look out. Okay, I don't know if you can hear it, but we heard a few little pops, about like a hand clap. That water was straight out of the tap, nice and cool. I bet you it's not cool anymore. It's still cool. You try and drop it through as much water as possible, or you can even add ice to it. What we're hoping is we got a whole bunch of small shots, smaller the better. So let's take a look. There it is. See how dark it is? A lot of crud in there we don't want. So we're gonna use potassium nitrate to help oxidize out all of that crud. And we're gonna use a little silica and a bunch of borax to help collect all of that crud. And that part will float on top of the silver.